All right, what's up, guys? This is question number 1 from the 2016 exam. It's a table question and it's a rate question at the same time. All right, and our situation is we have water being pumped into a tank at this rate here. We have water being removed from the tank at this rate in the table, and we have an initial condition at time 0, there is 50,000 liters. Okay, part A asks us to estimate r prime of 2. Okay, so that's just finding the slope between two values in our table. All right, and 2 is exactly halfway between 1 and 3. So y2 minus y1 over x2 minus x1 gives us negative 120. Now, r of t was in liters per hour. So if I find the slope of that, I'll be in liters per hour squared. So that's what that's about. All right, part B. Supposed to use a left Riemann sum. With 4 subintervals indicated in the table to estimate the total amount of water removed during the 8 hours, and then decide if it's an over or under estimate. Okay, so we have a 1 by 1340 plus a 2 by 1190 plus a 3 by 950 plus a 2 by 740. This is a calculator question, so you can just push buttons right there and you get 8,050 liters. Okay, now this is an overestimate because r of t is strictly decreasing. And over here, I drew a couple of different pictures of something decreasing. Okay, it doesn't matter the concavity. Both of those graphs right there, if I draw a left-handed rectangle, I'm getting an overestimate. Okay? Part C, use your answer from part B to find an estimate of the total amount of water in the tank at the end of 8 hours. All right. So we've done this type of question several times now. That's what you started with, plus what came in, minus what went out, leaves you with approximately 49,786 liters. And then part D, this one's the tough one. Between 0 and 8, is there a time when the rate of water pumped in is the same as the rate of water removed from the tank, and then explain. Okay, so I decided to sort of like have an idea or think about what an overall rate of change could be. And the overall rate of change at any time is the rate that it's being added minus the rate that it's being removed, okay? And so something else I thought about was, well, both of these functions are strictly decreasing, right? That one's pretty clear to see by the table. This guy right here, if you think about it, that e to the t squared over 20 would be like downstairs if you made the exponent be positive. And so as you plug bigger values for t in, w of t is going to get smaller. All right, so I checked my endpoints. W of 0 minus r of 0 is positive, and W of 8 minus R of 8 is negative. And so to go from a positive value to a negative value, you have to cross through 0 to get there, which means that at some point in time, W of t and R of t had to be the same thing. That's how you get a 0 out of that equation. So yes, the intermediate value theorem guarantees.